I don't know what I was expecting. Oh, that's not good. Okay. Close. Okay. That's better. Testing, testing, testing. Oh, that's not good. Okay. Close. Okay. That's better. Testing, testing, testing. Oh, that's not good. So. I think we're alive. I'm 15 minutes late. It's fine. It's fine. Okay. So we're going to turn that up a little bit. By the way, we're so close to this just falling on its face. I don't even know. Um, hmm. It's fine. It's cool. Howdy, howdy. Yeah, hello. It's been a long time. Actually, I don't. You use stream bitrate of 23500. You know what? I think I can maybe 23500. There you go. I have no idea if that's going to work or not. So, what do we have here today? We'll delete that. We don't need. Try again. Whatever, I will fix it later. Starts the stream before bootstrapping the IDE. Yeah, I broke my installation of Windows, so we're kind of winging it a little bit. I also I don't know if any of this sounds good, so we're also winging that. In fact, it's so bad that I have to install the Windows SDK. Actually, it's probably next. Oh Lord. Okay. That's yeah. I forgot the Windows SDK. That's important. Okay. I don't give you insights. Sure. Sure. Give me all that. Yeah, there we go. Okay, so the return of the simps. Yeah. We'll see. Uh I I don't know. I don't really want to do this at all. But we're doing it. Good morning, everybody. I guess that's fine. Okay. We have got yeah, we're doing that. So, you use the Windows SDK. You have to. You cannot build ReactOS with Visual Studios without the Windows SDK. You can do it with Rosby, because the Rosby comes with some of the stuff you need, but yeah. I mean, that makes sense if you think about it, and that's because we're trying to be compatible. Why not just use their SDK? It's fine. Who cares? And then that's kind of what we're going for. Eventually, I hope we end up using their CRT too, but that's another subject for another time. Anyway. Good morning, everybody, or good afternoon if you're normal. Okay, we need MS build for ARM. We need Spectre Negated for ARM. We need latest build tools for ARM64. Spectated for ARM64. We'll download that. Okay, so that goes away now. What else do we need? We need M4, I think. And I'm just going to set that globally. Oh, don't do that. System M4. Bison. Mostly because I'm extremely lazy, is what it comes down to. Yeah. Yeah, this is good. Jeez. What else do we need? Should we do VirtualBox Modern or VirtualBox Legacy? Let's do VirtualBox Modern. Let's give VirtualBox Modern another chance. It's good. It was good for UEFI, but for SMP, I'm not sure. Let's grab their latest. I'll grab the extension pack. Like that. Okay. I already see a problem. I wasn't sure if this was gonna survive doing a stream because I just set this up like 30 seconds ago. But now I'm even less sure because I killed my motherboard. Yeah. I killed it. Yeah. ReactOS SP. Let's do 2 CPUs. Let's do 512 megabytes. Create a virtual disk. We'll say that display is good. We'll say that that's fine. Actually, let's not do that. Let's get a serial port in here. Give me a host pipe. Pipe ReactOS. Give me Windybug. Windybug. Thank you. And we'll say that. Pipe ReactOS. That's good. That's good. I am arrives. Yeah, I did something stupid. That's why. Like that. I don't have an excuse. I just really screwed up. Why does Discord get worse every time I look at it? I'm dead inside. Me too. Okay, so here's what we're gonna do. If you don't know where we are dealing with a problem that I probably should be a little more. Cuts this Discord. Yeah, I know. I know. I know. I shouldn't have even asked. Let's do 1440p. Let's just pause. We don't need that right now. Okay, so if you were curious, oh, it's initial startup, isn't it? I hope that works. I think that's right. I okay. Okay. Um cool. Just get ugly with every version. It looks about like every Linux distro does now. So, for better or for worse. Wasn't obsolete is better somebody we're supposed to know? I don't know. Um but let's see. Here's what we're doing today. It's a it's a lot, but it'll be fun. More like slower since it's mammal. Eh. Something like that. Um so I think that is probably what I need to change. Oh, Jesus. Let's see. Um Nice. Make a fake ReactOS. Oh, hey, Retro, what's up? Yeah, you can do that. Um, what was I doing? I remember now. We'll see how this breaks everything. This is more concerning than anything else. Look at that video encode. Oh, that's beautiful. That's all it's doing. I want to see it explode. Anyway. Mm. Look at that. And now we got a dev environment. That's cute. Oh, that only took 30 minutes. Okay, so this is part 25. 25. Zero motivation to do this. But we're doing it anyway. So, previously on SMP Adventures, we attempted to fix the multiprocessor kernel. We attempted to get the mat tables parsed, and we've attempted to get processors started up in their initial spin up and get to kernel mode. And after this is 3 times. Yeah, this is the 3rd time that we're doing this. We we're trying to PR this again. Okay. And after every time that I've done this so far, this one's gone the best, I think. 3rd time's the charm, I hope. And we actually have a lot of really good advice. Shut the fuck up. Ugh, God, I forgot. I'm gonna have to deal with that. Hang on. Let me fix Defender. No. Stop. Oh my god. So, yeah. um, that's what we're gonna do. Um, yeah. So, what we've done. Defender's great. Okay. You saying that just means because you're not in security. Defender's awesome. But it does get confused with ReactOS code sometimes. And that's okay. I don't really blame it. We are doing stupid shit. Anyway. So yeah, we got a lot of good advice this time. I would show you where we are, but I really don't think it matters at this point. And I don't feel like dealing with it. So we're gonna think about this. Let's do some of the things that are a little off-put first. We're suggested to go into KE, KI in it, wherever that feels like being. Oh wait, it's an i3 And then go to where I freeze the processors and shove put a loader block equals null and a memory barrier to go ahead and allow the processors to continue. And that's a good plan. Wait, it's 0. No, not for the PRCB, it's 0. Okay. But same idea. Okay, that will let things continue, which is great advice. And if we shove this back on, we can see vaguely where we are, which is great. Okay. Yeah. We'll virtual screen this to 100 and we'll go bigger. 50. Okay. So really, all this code does right now is get things to... I don't know what's going on, but okay. Okay, hold on. Okay, so it boots fine. It's the fucking Windy Bug. Host pipe, serial port, COM1. You need to delete the frame buffer handle too. I had no idea, honestly. None. That's pretty cool though. I don't want to deal with this. What's your deal? Is it good now? No? Okay. Great. I think I'm gonna have to restart. Here, let's use Buddy for now. It's not Windybug's fault. I just built this install. I haven't even rebooted yet. It's fine, I wanted to test this anyway. Alright. Bam. simping to that. I don't know, man. I'm tired. This thing is not my favorite. Not my favorite thing. What the fuck is going on? I mean, maybe it. I don't know. Hang on. Let's give this a shot. Otherwise, we might be stuck a little bit. Nope, that was it. Okay. Okay. Whatever. Like I said, it's probably because I need to restart, but that's fine. It's fine. Whatever. Ugh. Okay, so that should be a little better. Okay, so the first step was to change that, so execution continues, which would be helpful. Oh my god, it's so big. All right, so you can see it detects a physical processor count of 2, and then it blows up. Let's go see what I fucked up. Probably it could. Oh, right, I remember. I left it in this state and I pushed some test code for it. So, I have to bring it back. This was the thing that was fine. Freeze. Jeez. Um. Mm, 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 mm. God. Okay, let me run it back a little bit. Oh, that's correct, actually. Oh. Let me pull up my laptop. on. Oh, yeah, I remember. Okay. No, that can't be you, Short. That's right. You're running over the buffer. It can't be you, Short. That's something I was gonna have to ask Timo about. These can't be you, Short. I don't remember if this is or not. Don't think that is. I think it's only those two. Really not enjoying this. Oh, I didn't even make a new one. I'm dumb. Yeah, I was doing it in the first place. I'll be right back. Okay, that is better. So, moving on. I have to try Windybug a couple times apparently. This, I didn't even open it with the right thing. What am I doing? That should be better. Okay, let's try that. There we go. Okay, so as what's happening here, what we're gonna have to do is convert this. Take this out. This needs to proc. This needs to go. And what did he say to suggest it to do? Read it once. Don't optimize. Okay, so what needs to happen is just grab this, verify it's not 0 before continuing, and then that should solve our first two issues. Well, they're not issues, but they're cons. Now they're issues. Okay. So if we do this, and then we do this, it's not 0. What the fuck? If I reload it real quick, get our symbols up. Yeah, so it's... Yeah. So, what's the problem? No. I could have just not saved that. This should... Let's put an escape here. Oh, duh. Hmm. Hmm. Um... I don't know. Oh, wait. Hang on, let me try something. Something really quick. think it's the address. Yeah, because the PRCB. No, I don't get it. Let me see. Let's do that. That's fine. Okay. Let me read what they said again. So we want if we're thinking about what we're doing here, KE loader block assigns a PRCB pointer, and this as the pointer should be null. So if we stop here, and then it's 0. It's that value. So what's happening is the processor is never actually reaching that. Because if what's happening, like what happens normally, is that this value gets changed in ki initialized kernel, which I think it's in the other file. Wow, what the fuck keyword did I do that? That happened. Anyway, so that's changed here. RCB equals to 0. So this processor is never reaching this for some reason. I don't know why. Here, let's remove this debug break. I can't enable debugging for other processors, sadly. That's not something you can do. Well, I can get close, I think. Here, let's move this around a little bit. So instead of doing this, let's do this. Okay, put it here. Remove the memory, or remove the memory barrier after that, I think. If I understand how that does correctly. The processor after that. Okay. So I should have access to interrupts now, which means I can deprint. So deprint check or something. And that should cause a port lockup because it's not implemented. Yeah, that's something that happens. What? Oh. Okay, that should lock. Let's cause a spin lock. And it does. No. It doesn't. That's because it never gets to it. Here. Let me just there. Add that back later. Just right before this. Right after it just tries to set up. If it's not the CPU. You know what's weird? I don't think it's getting there at all now. It's not. Okay. Hang on. Let me revert this. See if that was the problem. Because it just doesn't really make sense, but I guess it could be. So, yep, that was it. Escape. Starting to CPU 2. That print is shitty. Hey, no, let's not use that print then. In hindsight, that's a bad idea. Okay, so reverting this. So it should be there, this should be there, this should be there, that should be there. We'll leave this because it's funnier that way. So I have something to check for. This should hit now. Okay. No. Let's go back up here. Put it there. Oh, wait, no, I know why that's failing. You know what? I will fix that another day. I know why that's failing, actually. That makes a lot of sense. That's really dumb, actually. Okay. So, now you can see that it says one system processor, which is weird, right? Why does it say one system processor? We have two. Well, that's because this is where that number is actually updated, and we don't even get there. I can force it to get there, but let me first fix this by adding in what the problem was. Let me set this up. Use the legacy mode. Get that. See my clipboard. Oh, well, look at that. I didn't save it. That sucks. And there we go. Okay, so now we have I see interesting things are happening while I'm doing this. Anyway, so we can look at why this fails real quick if you want. Although I've got a feeling I know why. I think it was this that this thing never liked, and I think it was because for some reason not all of the CPU features exist. Like they don't all the CPU ID doesn't have all the same values on ACs. I think I'd have to look. I don't really care honestly. I'll fix it later, but I don't know a whole lot of 100%, so I don't want to touch it. But if I did touch it and I did fix it instead of just doing that, this should actually pass now. And this would show up. See? There you go. Whoa, SMP. Ooh, spooky. I know, very shocking. Actually, this is the other thing that's really bad. Because this was one of the other PRs that I was doing was fixing this cert. Because yeah, this one's bad. This will infinitely wait forever. Because the way this works is that you're supposed to flush the TLB after every like context switch. And so the moment this finishes, right, we're going off and okay, get back to what you were doing and flush TDB. But it flushes it on every processor, which is fine. That's actually supposed to happen, but it's implemented in ReactOS a little janky. It's I think they were trying to estimate what it would eventually work like. And they got close. So there needs a small fix, and what that small fix is basically turning the TLB into an IPI packet and scheduling it on all the processors like Windows does, and that's Windows Vista, not. I don't actually know what 2003 does there. I'd have to check, but it's probably the same thing because the scheduler didn't change much until Windows 7. But yeah, that's a fun fact. But yeah, that's the original attempt at this PR got this far, but I disabled this, and I don't generally think that's a good idea. I could. I'd rather just ask. There's no point trying to hack things together right now. It doesn't work anyway. I might as well put the bases solid down. So this is a good place to stop. Just ignore it. Don't cause any trouble. Just forget about it. Just they're started and they're frozen. Okay. So what this solves is this entire thread. That's the first one. The other one was that we solved just now was this. So that's a little better. Okay, so those two were the really easy ones. It's not too bad though. None of them are all that bad. So there's a couple questions here And then they're open. The way this kind of works is they're open-ended suggestions where this is the right way to do it, and why are you doing it this way? So, cool. All right. Some of them are really assembly based, and I've never been the best at assembly, but he made it very, very clear what I'm supposed to do. So that helps. The biggest problem, I think, the first one that probably needs to be done is I need to pass processor state as a pointer into like AP entry, like he suggested. And then fix the pointer calculation. So a quick overview of why this is kind of a sketchy idea. I knew it was sketchy when I made it originally, but we're gonna have to fix it. And I don't think I understood why it was sketchy originally, but then I read the C specification. I think I got an idea now. So we're basically writing the 16-bit entry code and then calculating the offset based off the low stub and then the actual jump we're going to make. And so it does this like 2-part copy, and it's entirely based off the size of the different chunks of, you know, execution we're doing. So that's not ideal. And then, yeah, so the suggestion here was that, okay, instead of doing it like this, the CPU state could be replaced with a single pointer, and the ASM could be this. So instead of copying it in all those different segments, it reduces the amount of pointer magic we have to do a lot. And I understand the concept there. It's AP entry data, which you gotta understand, I'm not very good at ASM, but I know how to do it. So that's a start. But so it worked, but yeah. Not very well. So and yeah, you can see why he suggested this the way he did, because that's a lot. A lot. Okay. So by the way, you can calculate this with EBXCS. EBX. Really? I did not know that. Is this directly documented? So I think what we'll do is we're gonna go from the start and then go backwards. And what we're gonna end up with is that these pointer problems are going to be the last two things that are going to be dealt with, and that should make things a little more bearable, and we can focus on that all at once. So let's just jump around. You're setting this to the stack base minus 2 pointers. This is a suggestion, by the way. This should it be original stack base? And I might not get all this today. I might not understand all of it. I might have to ask some questions. That's okay. I might just use non-page school must succeed. Okay. That's a good idea. Oh, is this an... Oh, yeah. So... Okay. That's resolved. Asserting that these two situations are valid because the function assumes it anyway, which is really true. I probably should also fix this name scheme, which is very, very wrong. Very wrong. So, it's inside Apex Simp. We have 3 instances. We call it this. This is the starting processor count. Oh god. Oh, you know what? I see what he's talking about now. Going back up. This is wrong. Nope, I thought he was looking at something else. I should have looked deeper. Damn it. Oh, that's wrong. That's wrong. He's right. That is not... Yeah. Okay, I should have looked at what he was looking at better. Okay. So from there, I recommend asserting that that is equal to 0, and then assert that this high part is 0, and then assert that this loop is true. Okay. Oh, wait. It's quad. It's quad. Cool. This is documented. Yep, it is, actually. So let us pull up the multiprocessor specification. The Intel multiprocessor specification. I have to find it. And if you look at this, there is a section where it talks about startup. We have to find it. Using an application processor startup, which is in B3. It's actually a 2U second delay. Which, oh, I see why I did that. Oh, you know what? It was OS dev that said it was a second. Oh, you know what? It's fine. Yeah, it wants you to start it up twice. You suck. Microsecond stall execution processor is in microseconds, right? Microseconds. Yeah, that's fine. All right, I'll do it like that. 200. Oh, wait. Yeah. No. Is it milliseconds then? This is 10 milliseconds. BSP delay is 10 M seconds. I don't... This is milliseconds, right? 10 milliseconds. So MPS spec B.4, B.4, 4. It is maybe it describes it somewhere. Yeah, 10 milliseconds. Okay. 10 milliseconds. I think it's 10,000 microseconds. I was missing a 0. Very cool. I was missing 1 0. Nice. There we go. Go for it. Go for it. Yeah. I don't know why chat didn't update for like 30 seconds. I'm sorry about that. I totally ignore it. Chat GPT would know what's up. Yeah, I'm American, and so I don't know the difference between nanomillion microseconds. I have to look it up every single time. I kid you not. Look. Anyway, it's easy, but I never remember it. But anyway, moving on. Okay, let's do this one next. Use early exit instead of if else. Okay. Oh, why do I have 5 files named the same thing? That's really stupid. Anyway, it was talking about this one though. So processor count. Yeah, okay. Whoop. Whoop. Oh, that's not what I wanted to do. Fix your spacing. You like my insurance? This is how I'm making sure that our boy doesn't backport it. This single line. That's it. That's my insurance against our boy backporting it. That's it. Anyway. So, basically, while started processor count, which is a global variable for some reason. I don't like that. But okay. Well, that's... If it's greater, then we exit. Pretty simple. Okay. Alright, we changed a couple things, so I should probably make sure it still boots, huh? Would that be the smart thing to do? Probably. Whoa, shocking, it still boots. Crazy. Anyway. Alright. That's the boring ones out of the way. Now all we got is fun stuff. I guess we have to do this too. Okay. Current default stack size. I changed this in so many spots, so this is going to take me a second. There's 3 by... There's 4 places it's in. So we'll do this. But we're going to move it to XDK. Oh, wait. Go to NDK. NDK. What I found in the internals was a delay of 20 to... M10. Is M second, not milli? I might be dumb. What is this then? What is this symbol? Hold on. Now I need to look it up. Micro symbol. No, okay. Big brain. BSP delay is 10 milliseconds. I mean, this is the one I was going for. But you're the boss. I don't mind either way. Bro, that's a moo? Oh no. See, I don't know. Okay, we'll do 20. See, yeah, that's that's the American education system for you. 20. Okay. That's funny. I'm gonna have to recompile this thing because I changed the NDK. KE types. Where should I put it? Where should I put it? E flags, MSR, IPI, PCB, HAL values. And it's not HAL. I vote laptop. We'll put it here. Hey, is it gonna... Whatever. Double false stack size, even though you can just read the variable, and that's not necessary at all, but hey, who am I to judge? Maybe you don't want to read the variable. It's fine. It's fine. We need to open ARM64. But I'm not doing it for this one. So to remove that. AMD 64 there. That, remove that. And then AMD 64. Fuck! I did it to the wrong one. I'm smart. Big brain. Okay. Now AMD 64. Put it in the bottom. That should make everybody happier. That's a moo. Okay, that should be all the boring stuff now. Now we get to the spicy things, where we really start to question whether or not I'm alive at this point. Do you want to install it? Happy? I don't. I really don't. I don't care. I don't want to install it. Leave me alone. Structure from the complete. So it should probably be done by how. So let's see. We go into what they're talking about here. We go to mproc. Push null address on stack as return address. I see why he says we should do this in HAL, actually. That makes sense. But I assume that we're going to represent... Oh, wait, no, that makes a lot of sense. Wow. So instead of doing this calculation, we're removing a p void from the stack each time. This thing, so we can just make a structure with two p voids, and like you said, and just do it. Okay, that makes a lot of sense actually, and that is probably not very hard. So let's go ahead and do that. So if we're doing this in HAL, we can do it in HAL. We have just a blank p void and one that's set to loader block. So let's grab this for reference and remove this here. Going back into the SMP component and going into spin up, we can find this one. Right? Start next processor. Let's make a structure here. Struct test. I don't know what to call it. Set up stack. Set up AP. Whatever. Anyway. Set up AP stack. Set up AP stack. We'll have two p voids. Return adder. We'll have the loader block. We'll say the localization. What we're doing is basically we're going to be replicating this. We should have kernel stack access to kernel stack in here somewhere, right? It's an ESP. I'm 90% sure it's an ESP. Because we already put it in ESP, right? We totally did. We're smart. Okay. So, inside ESP here, we'll put I guess we can remove. I guess it's gonna be something like this, where we're taking the size of kernel stack and then we're taking it to the address that is this, which makes a lot of sense, I guess. Kernel stack is equal to the kernel stack minus the size of the state AP stack setup. What is it? Okay. So AP stack. So something like this, where we're moving it in, I guess. But I think there's other places that I changed the stack, no? I'm pretty sure there are. Or maybe there's not, which is probably part of why he suggested it like this. Okay. um. That's literally it. Wow. Okay. So right, KE loaded block onto the stack. I don't know. I got this. We're gonna take the address of this, which is wait. No, we're not, because we're using null variables. Wait. Think about what's actually happening here. Because if you remember, the reason we're doing this is because we don't push it to. What we do is we turn kernel stack. What the fuck? Really? I mean, I guess. We minus it by AP stack kernel stack, and then we turn both those into. Okay, I think I got it. This is actually going to be equal to this. Which is equal to, if we go back to mproc, directly this. So set up maybe stack this, right? Yeah. Yeah. I think. I have to think about it. No. 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 You want it to point. No. Not like that. it's set up AP stack is equal to this as a because we're taking the U-long pointer of this, which then is minused by the AP stack itself. Right? Why is it like that? Yeah, so... Oops. Setup AP stack is equal to that, which is being offset by the size of the AP stack, which means that this is now pointing... We've pushed two null values, I guess. So now we're going to change them, which would be the KX loader block, which is equal to loader block and then the return adder is going to be null, so we can put null address. And I think it, if I'm yeah, should be like that now. This should go away. So we're basically creating this structure. It's set to an address, that's ESP, which is actually kernel stack. And we're minusing it by pushing two null, basically pushing two empty values in, so pointing it slightly up. Yeah, pushing it slightly. And now we're actually assigning that to those. So why? So we're dereferencing. That's not allowed, actually. Because now we're... Oh, let's see this again. Because we have access to people. Removing it. Okay, I see why that makes a difference now. I think. I see why this makes a difference now. Bruh. I'm literally looking at the ISO spec. That's how bad this is. Making sure I understand the concept. Because if I follow instructions blindly without getting it, I'm never going to learn anything. Okay, I think I see why this works now. I might have to convert this to a P void. Hang on. P voids. P voids everywhere. This should work. Okay. This should work. Okay, so why does it work? So, we have this structure. It's two, basically, you know, in this case, 32-bit addresses. We're removing the stack, and then we're, instead of pushing it one value at a time, we move it twice, and then we have pointers to both of those locations, and then we're assigning those locations to their actual values. So what I don't understand why this is slightly better. So let's ask. Just cuz. Okay. Let me ask because I don't understand why it's better and that bothers me. Push values on stack. Better. Okay, I asked him. Let's move on. I think that's what he wanted. But just in case. Yeah. Okay, so that's maybe that solution found. I'll leave it open for now, but I think that's what the solution is. We just can, let's remove this. I totally forgot I did that. I left the other one there. Here, let me make sure it still works. It shouldn't make a difference. We just pushed it twice instead of once. But it should still work. All right? Yes. Okay. Okay, so very cute. This P void convert is probably not needed. Quick question: is it useless to call close handle on a handle after using invalid handle? I don't think so. I think you should clear it anyway, just in case you don't have any used memory. But I'd have to look at the implementation of that function. Redundancy is normally bad, except when memory is involved. First of all, PVH wrong. Is your structure to have the proper types already? Oh, you're right. It should. This should be a struct, the adder, because this is an address. So the address of floater. No, no, that's already fine. Right? So this thing. So this thing. Because yeah, they're already set up right up here. That's fine. No, why is there a... He's right, it's not needed. You shouldn't be doing that at all. It's just that. Oh, because they're both individual pointers. Okay. That makes sense. Yeah, because what we're... Yeah, okay. I get it. That... The struct... Okay. Never mind. I'm dumb. Okay. Cool. I got it now. Okay. Cool. So, P void. Yeah. It should be this. So set up a loader stack minus... Oh! I start... If we're using... See, I'm glad I'm asking because I don't always know. Yes. Yeah. 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 It's written. Reload it later, which is kind of dumb. That makes sense. So EIP. Which probably isn't necessary. See, asking the right questions. Okay. All right. Hopefully, this will be good then. So, kernel stack, kernel stack. Do this instead. Grab the processor state ESP. ESP. And then load this, which this should be the AP stack. Stack equals to AP stack -1. Okay, so this is correct now. Must point to a structure union. Oh, yeah, hang on. Okay. Okay. So this is probably closer now. So let's change the name a little bit. We're gonna have something like, I don't know, AP setup stack to keep things consistent. PAP. Okay, so that's correct now. We'll keep it like that, which means that's our first fun one we can resolve. Okay. So, next problem. You know, that's a good question. Why am I doing that? Oh wait, I can just copy the thing from here. So, I think the question is, what is this? Me too. Man. Wait, that's right. I remember that some of the stuff Timo said to me in like my first PR was hilarious. It was funny. I have to find the right one. This is always my right. I'll find the one. I have to find it. It's somewhere in here. Remember. There it is. Always remember. Anyway. I feel like there was the reason I'm looking for this is because I think there was somebody that was telling me to just do parts of processor state. I'm pretty confident there was, and that's why we did it like that. I think it was Victor. I don't really care, honestly. If it makes things easier, it makes things easier. It's really just up to the people reviewing it. I don't have an opinion on it. Man, some of the things they did are weird. Super weird. Something, something, good old times. I'm pretty sure it was Victor that said it. But maybe it wasn't. Oh well, let's do it. Ew, gross. That was dumb. I did the dumb things. Whatever. I'll just do it like that then. If someone else wants to complain, they can say. By the way, did I push everything? Is this updated? It is. Oh, I should probably do that. So, the biggest one. Oh, actually, let's do something really quick. I'll be right back. here is the plan. Chat is dead as fuck. Okay. And don't be cringe. We'll put that there. Put that there. So, the biggest thing being told to me, and should have the original stack instead. Well, oh, you know what? Oh, wait. We'll have to see about that one. Can't even do English. What is English programming? What does that even mean? What about just hard coding it to K, GDT, R3 data? I mean, yeah, sure. Hmm. All right. So in the PCR, something like this. Mm-hmm. They don't the same page. Yeah, but how would I get processor still? Wait, you know what, actually? It would just be lined up because of what we're doing. It's kind of stupid, actually. Oh, right. That makes a lot of sense. Yeah, okay. Each value would be okay. That makes a lot of sense, actually. Mm-hmm. Hmm. So, hmm. Okay, I get it. His He's very right. What we should do is put this in a different spot. Hmm. I think the biggest takeaway there's two takeaways from the statement he's saying. So for one, the calculations of the different pointers and point arithmetic magic is bad, which yeah. And two, really wants to minimize um really wants to minimize all of this weirdness. All the 16-bit code. And he's right. There's a couple ways to do it. CPU state like this. Yep, sync with. But then my other question would be, because he was managed to do it in a way that doesn't care about having 16-bit code by define, because he basically sent me the solution for AMD 64 too, for context and stuff, and there's seeing what he was trying to do in implementation is actually really cool, for one thing, and then two, It kind of really shows me where I'm going here. Yeah. Moving to PS context. That's such a cool trick. Mm-hmm. Sorry, I'm trying to make sure I understand why this is the way it is. Okay. Man. So I don't know. Maybe like low stub end in the bottom. Make it one copy, two copies, right? Mm. 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 Uh, the biggest thing this is showing me is that I'm just very, very meh at assembly in general, but that's okay. That's how you get better. Yeah, it's weird that we actually copy. What is this? Four times? Yeah. So we create a we actually move memory manually 4 times. And then we have a pointer to CPU state, which we then copy everything. And he's right, it really can be simplified very easily. But just like looking at it though, I'm like, I kind of see it now. That's a lot of pointer magic. That's a lot of pointer magic, actually. We know that we know we can figure out the end of the entire boot stub code, and then the start of the boot stub code. Okay, so that's one copy, RTL copy memory, and that's all you should need, because from there you can just go ahead and create this pointer and stuff instead of copying 16-bit, copying 32, copying page tables. Yeah, that's kind of wild. My What are you doing? Jeez. Okay, so yeah, I just like looking at this though. I'm like, huh. But yeah, I mean, a processor state isn't a bad idea. I mean, shouldn't be too hard. But yeah, just in hindsight, that's pretty wild. I don't know why I separated it like that. I'm trying to remember why I did that originally, but I don't think it makes much sense. I mean, maybe I thought that I had to keep it all so separate, but this also shouldn't even be here. Just for one thing. That's kind of weird. Uh, should be there. Hmm. So then, okay, in load temp page table, long jump, right. You know, the other thing too, you don't even need to do this here. Hold on. Hold on. Let me just like lose my shit for a moment. Okay, so we don't even need to do that. This can just be, we could only like, okay, so load final GDT, load final IDT. Okay, so that can be in 32-bit code. I'm pretty confident. Okay. Yeah, that's... Yeah, literally. Like, you don't need a lot in here. Yeah, so we load a GDT, we load a page table, and then we enable paging, and then we jump. That's the entire 16-bit code. from there, end code 16. Is that why I did it like this? But that doesn't make sense. Okay. Because relatively, how am I okay, hold on, how am I copying this? Because oh jeez, look. We're taking the how load stub. We're taking a the address pointer of this location, and then we address this location. Pointer. What am I saying? The address of this location, and then we're doing the entry. Minus the entry, minus the state. Because this is the state, I guess. I yeah. Okay. Wow, we really do not need to do very much. Okay. So, instead of taking the end here, we'll put this here, and then we'll end code 16, and then we'll end. So, the yeah, that is so unnecessary. Okay. Yeah, I get it. I get it now. Okay, so we have the page tables. Cool. Got the low stub, and we're gonna change all these weird copies here in a minute. But for now, we're taking the address of this minus the address of that. Okay. So minus AP entry 32, which should be in here, right? This is a thing we have access to. Okay, so minus that, minus the AP entry state, which is now down here. Should the page tables be high? Should they? Should they be in 16-bit code? Should they really? I don't think so. I really don't think so. I do not think it matters. It shouldn't be like that. In fact, even Timo doesn't think it should be like that. You just have to make sure you're not low. Yeah, you have to make sure you're doing it relatively. So, right, this. So this, I guess. Must be in the same segment macro called from. Oh, that's why. That's why they're like that. Okay, fine. But what if we... Okay. And then, I don't know, like dot long. 0. Okay, so there's a buffer there now. And then this is what it actually ends. 16-bit code. Shouldn't matter. Because we're not even in 16-bit code very long. And this will probably explode. This one will probably explode. Or not. Huh. You know what? Now I'm starting to have some questions. Okay. I don't... I don't think it matters. Okay. Um... It still boots. Okay. Okay, what about, what about the picky one? What does the picky one think? Okay. Redundant data 32 prefix, which is true. It is redundant. And then, where is the other one? Where? 60. Oh, yeah. Okay, not even GCC cares. Okay. Like, if GCC doesn't care, then you know something's up. Hold on, we're just gonna... Zero shits given. Just zero shits given. Okay, so no, we really do not need to do that. Actually, this is just stupid. What we're trying to do in practicality and thinking, like, okay, so I was trying to do things like, by book, but yeah, okay. I was thinking too hard about the startup sequence. So here's what actually happens. Okay, we need to write a chunk of memory that contains all this low stub code. Right after that chunk of memory is going to be a pointer. So at the end of that chunk of memory, it's going to be one pointer to an entire structure that has all this information that we can totally write from relative space anyway. So this processor state and special register shit all does not matter. Okay, so the GDT and stuff we can just load from the kernel immediately. So that's all we need to do to get to protected mode. So we don't even need to do any kind of jumps or anything or crazy, you know, like, okay, refresh everything. We just jump to the right label. This is executed as 16-bit code, but it's in, you know, 32 space. Just like the 64-bit one is one that actually makes way more sense. Because, yeah, it's... Yeah, okay. Wow. Okay, so we have an end, we have a start. Let's just start abusing this. Okay, let's create this structure that, you know, Timo suggested. So if we go back up here, we have this entry state and special registers, but that's dumb. That's dumb. Why would we do that? All we really need is this. You know, we have the self pointer, we have the page table root, we have the processor state GTR, and then we have the offset segments and jumps. And actually, those offset segments and things are actually pretty easy because what we're practically doing there, okay, so we write the segment here and the pointer here, but we don't even have to do that either. That's also stupid because we can just sign it with the very... Wow, I really didn't... My first go at this was not really overcomplicated. Okay, I get it. I understand now. I understand why this is overcomplicated. That explains so much. Wow. That's awesome. Very cool. Wow. All right. So if we even have access to processor state here. So what the fuck, right? I think what I was getting confused by originally was the fact that we don't initially map it a long time ago, but we do now. It doesn't matter. We map the 32-bit mode entry point, and then we map the GAT because the 32-bit mode entry point's relocatable. None of that matters, right? Wow. I don't know if what I'm about to do is going to be closer to the right, but I think it's going to be a little better. It's just not that complicated as I thought it was supposed to be. Yeah, because... Yeah, it's... The offset segment and jump. Remove that. He even made it easy for me. Yeah. Yeah, this is just kind of all wrong. What is this? What is the point of this then? Processor state LETR? Oh, what the hell? Yeah. Roof. You're right. Food. I should make food too. Um, yeah, I can simplify this a lot. We're doing all this weird kernel, PS kernel thing because it matches what's written and register and. Well, I'm gonna get closer, I think. Dollar door turkey. Dollar store turkey, that's pretty good. I want some food. Should probably cook something for myself. Yeah, okay. Oh, yeah, yeah, okay. This is just interesting. So yeah, we're gonna need the sure. And then the one. EVX. The single pointer. I. Wow. I think I get it. I think I do. Processor state and CPU entry state. This whatever minus. processor state base address. Why copy this instead of passing a pointer to processor state? I kind of get it. I kind of get it. But hard coding it. This has just been shocking. Oh yeah, there's still like Val returns. Apparently. That's cool. So by the way, with all the changes I've done today, do I still make it as far as I want to? Let's check. I probably should have done this. We'll do this now. Need leave it here. Oh, let's do it there. And then this. If not CPU. Let's see if we still get to a fun point. I'm pretty sure we should, but just in case. We don't ever know. Oh, what? Oh, oh, oh my. Oh my. 0. 0. What? Oh my. Uh-oh. Uh-oh. We found an oopsie. We found a big oopsie. If the processor count is greater than... Oh. If the processor count It's less than the processor count. Then we do stuff. I don't think it's been actually starting this entire time. That's not good. What the fuck? Started processor count. Well, it's equal to 1, so it's less than, or less than and equal to. Okay, duh. All right, nice. There we go. What the fuck? Oxy, no. No. Starting CPU 1. What the fuck did I do? Oh, this is opposite. Yeah, okay. So while processor count, so if it's so if wow, I'm sorry. I'm actually probably really tired. I've already been doing this for a while. And it's been a long time since I've streamed, so my brain's probably frying a little bit. Okay, so sorry, we want start processor count's 1, we want it to be 2. So if starter processor count is, as long as starter processor count is less than, but if it's actually equal to already, then we false. So if it's already that value, then we're false. There we go. That's what I wanted. Okay. Now we can test this more accurately. So let's go back up a little bit. Okay, so now we have this IDT. We have this GDT. We don't need to set the IDT in yeah, space. I need to set it up in this one. All right. Right? No, wait, hang on. Change that back. Because it'll go into random spots. It's my favorite game. Oh. God damn it. God damn it. Uh-oh. 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 Okay. Port lock was not fired. What? 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 Stop. Isn't that? I don't remember. GCC's always been a pain in the butt. What? Okay, can I at least figure out where this is failing? That would help. Yeah, let's look at it. That's not what I wanted to do. That's really not helpful. I want my logs. Give me my log. Give it to me. Thank you. Okay. What the fuck? I don't know what I did. Let's make sure that's not it, I guess. I mean, it's the only thing I can do. I really don't think it is, though. I think we did that right. Mm. No, I'm pretty sure we did that right. Try that. It doesn't even use that. No, that's right. Yeah, that's fine. Okay, so now we'll halt here, grab a descriptor table. Do something else. Maybe I was compiling with the other one on accident. Okay, that's probably what I was doing. Okay, let's try jumping to. Let's try. Just enabling paging. This should still work. Should be fine. Yeah, okay. That's fine. Don't go to kernel, but freeze there. Okay, good. Now we go to ki init. If you were another processor, freeze. I don't know. Here. Just do nothing. Oh, I was compiling with the other one, I think. Okay, that makes sense. I was just being really stupid. No, I wasn't. Oh my god. Port lock not acquired. Say, can you see by the dawn? Say. Oh, wow. That was what I was fucking humming. Oh my god. Oh god. I'm dumb. I was like, what the fuck are you talking about? Wow. Wow. That's what my brain does sometimes. I'll start humming random shit and I don't even realize. Oh god. That's fun. Oh, dark. Oh, dark. I I don't know, but I think JCC is having a problem. Aneurysm. In fact, I'm pretty confident it is. Well, let's verify I'm not crazy first. We're so proud. It's funny. Mm. Um. Um. I don't. I don't think that should be a problem. You know what I just realized? We're reassigning this for every time the processor boots up. For every processor that boots up. We're reassigning that variable. That's really weird. That's nice. Can I do that without getting in trouble? Just shove it in there. This only happens once. Mm. 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 That might just be a nitpick. I don't think it would matter. We're assigning it to the same pointer. I don't know. It's gonna annoy me now. I should go get food, but I want to figure out what I regressed first. I'm pretty confident it's something to do with... So, do I just... I don't think I did anything else. Oh, yeah, ignore that. It's fine, probably. What the fuck? Alright, so why would... I don't know what it's asserting on, or why the other processor's asserting. That's really weird. Or BSODing, I guess. I don't know, it's spin lock, it's getting locked on, but it shouldn't. Unless... No, something would be printing. Something's printing somewhere. What does this actually do? I think this is just calls right into a... Yeah, something's BSODing somewhere. Or printing. I'm not calling it BSOD, sorry. This is just like a macro, right? This should be fine. We'll check. This should be fine. Let me make sure. Yeah, this is... Yeah, this shouldn't be any... That's not... No. That's not it. I don't know what would be causing the problem. It's not doing anything. Like, at all. Come on. Nope, what the fuck? It's doing something. It's getting there. I don't... There's like 4 things happening here. What could possibly be the problem? What is printing? God. Initialize machine type. That can't be it. Although we probably shouldn't do that on every processor either, but look what I know. This can't be it. You'll check, but... Am I gonna have to merge my freeze code just to debug this? Because this is gonna piss me off. That's amazing. Wow. Is that a macro too? Indeed it is. That's not it. Loader block, kernel stack. Oh, you know what it is? I know what it is. We set... Okay, I think I know what it is. Let me put that there. I think I know what it is. We set this... We moved the kernel stack a little bit, right? With this change we did, because we put this in HAL. I bet you it's because we never adjust for it here. So if I return this like it was for a moment, this is probably what it is. We probably just need to move the stack back. Or no, because we don't even have to move it away from HAL. We can just adjust for it, I think. But then I don't want to share that interface, so I don't want to hard code it either. That'd be kind of cringe. Yep, that was it. Okay, so that can... If I put this back here, yeah, sure, it'll work. But I kind of want to keep it in HAL. Just because it being in HAL is cool. It doesn't have to be, I guess, but... Let me make sure my... It's back here for a moment. Yeah, so the K loader block was null. Became null, sorry. Processor state undeclared. Context, what the fuck are you talking about? Oh, yeah, that makes sense. Kernel stack loc. I just need to adjust for it when I give it back to the thing. No, no, wait. KE loader block. Yeah, it was 33 years ago. What about it? Shut up. Okay, so now I have this working, but now we need to move this back. So we change the way... Oh, no, wait. It didn't like that. No. So it wasn't the fact that I didn't change it back. Well, important. Be as easy as loading the pointer that makes sense. Okay. That makes sense. What's your deal here? What's your dealio here, yo? Oh, I see the problem. It's... Yeah, okay, so we're setting that to... You have to adjust it. Removing the stack value. This thing, it shouldn't line up anymore. Because then we're writing it back, I think. Yeah. Nope. Wrong one! No! Okay. Yeah. We have to change it in K... That was loud. What are you doing? Me too. So we have to change the... No. Oh my god. I am getting spammed. I probably have to go, actually. Alright, I'm gonna keep going on this for a few minutes. I need to move this back into HAL and then finish up the assembly, and then that should be good for getting more comments. So, thank you all for watching, and I hope each and every one of you each and every one of you has a good day. I'm gonna get some food and then I'm gonna get back to this. So, see ya.